All right, everyone, let's dive in. Vasculitis. Look, we all know it can be a really daunting topic, right? Whether you're on the wards or prepping for an exam, it's just this huge, complex group of diseases. So, what we're going to do here is build a clear, structured framework, something you can actually use day in and day out.
So here's the big question, isn't it? With all these different names, presentations, and pathologies flying around, how do we get a grip on it? How do we build a mental model that's actually useful when we need it most? Well, let's start building that model right now. Okay, so the bedrock of how we're going to organize all this is the system we all use, classification by vessel size. And that, of course, is the Chapel-Hill framework. This is going to be our main tool for getting all these diseases sorted out.
You know, the beauty of the Chapel-Hill classification is its simplicity, really. It just categorizes primary vasculitis based on the size of the blood vessel that is predominantly affected. And that word predominantly is so important because you will see overlap, but this gives us a fantastic place to start.
So let's start big. I mean, literally, with a large vessel vasculitis. We're talking about conditions that go for the aorta and its major branches. And there are really two main ones you've got to have locked in your brain. Giant cell arteritis, which we all know as temporal arteritis, and Takayasu arteritis.
And look, here's the super simple way to lock this in. For large vessels, just think of the two T's, temporal and Takayasu. It's a simple little mnemonic, but honestly, it's incredibly effective when you need that quick recall.
Okay, moving down in size. Next up, we've got the medium vessel vasculitis. These are the ones hitting those medium-sized arteries. Think visceral arteries and their branches. The three you absolutely have to know here are polyarteritis nodosa, or PAN, Kawasaki disease, and Berger's disease. And yep, we've got another great mnemonic for this one. For medium vessels, just remember PAN, Kata, Bacha. It perfectly groups polyarteritis nodosa, Kawasaki, and Berger's. It might sound a little unconventional, but trust me, it sticks. Now we get to the small vessels, and this is where things get a little more detailed. We basically split this category in two, based on the mechanism behind the disease. So you've got the ANCA-associated vasculitis on one hand, and the immune complex vasculitis on the other. And getting this distinction right is absolutely fundamental.
So let's look at that first group, the ANC-associated diseases. These are probably the ones that come to mind first for most of us. You've got granulomatosis with polyangiitis, or GPA, eosinophilic granulomatosis with polyangiitis, EGPA, and of course, microscopic polyangiitis, or MPA. Now for the second group of small vessel diseases. These are driven by immune complex deposition. The two big examples here are IgA vasculitis, which you definitely still see called by its old name, Henoch-Schönlein purpura, and cryoglobulonemic vasculitis. And hey, just to make sure we've covered all our bases with the Chapel-Hill framework, there's one more category for conditions that just don't play by the rules: variable vessel vasculitis. The classic example here is Behçet's disease, definitely one to keep in the back of your mind.
So vessel size is our main framework, but, it's not the only way to slice this cake. We can also look at these diseases through other clinically useful lenses, like their shared pathology. And this can be incredibly helpful when you're working up a differential. So first, let's look at it from a pathology perspective. Which of these conditions actually form granulomas? This is such a high-yield way to group them. It includes our two T's from the large vessel category, giant cell and Takayasu, and then, no surprise, the two small vessel diseases with granulomatosis right there in the name, GPA and EGPA. Another lens is the underlying mechanism, specifically diseases driven by type 3 hypersensitivity, immune complex deposition. This group pulls in IgA vasculitis, SLE, PAN, and cryoglobulonemic vasculitis. And this is a great example of how things overlap, right? A medium vessel disease like PAN sharing a core mechanism with small vessel diseases. So how do you remember this group? Simple. A really useful mnemonic is HSPC for HSP, SLE, PAN, and cryoglobulemic vasculitis. Keep that one in your back pocket. It's a good one. Okay, let's really zero in on the ANCA-associated vasculitis for a minute, because we can't just throw them all in one bucket. The serology tells a huge part of the story, and you absolutely have to know the difference between C-ANCA and P-ANCA. It's just non-negotiable for diagnosis and management.
Okay, so let's break this down, because it's critical. On the one side, you have C-ANCA. The C is for cytoplasmic. Its antigen target is protease 3, or PR3, and it gives you that diffuse cytoplasmic staining. The classic disease here is GPA. Then you have P-ANCA. The P is for perinuclear. Its target is myeloperoxidase, or MPO, giving you that perinuclear staining pattern. You're going to see this in MPA, EGPA, and also in other things like ulcerative colitis.
So we've looked at this through a few different lenses, right? Vessel size, pathology, serology. The real key to mastering vasculitis is seeing that these aren't separate competing systems. They're overlapping views that when you put them all together, give you a much richer, much more complete picture of what's going on. Let's use GPA as the perfect case study to pull this all together. Looked at through the lens of vessel size, it's a small vessel vasculitis. Through the pathology lens, it's a granulomatous vasculitis. And through the serology lens, it's our classic C-ANCA-associated vasculitis. See how that works? It perfectly illustrates how one disease fits neatly into each of our frameworks.